Good evening everyone, thank you for joining me for a very quick video where we're looking here at the significance of the equilibrium constant. I am Mr. Ish. A chemistry topic, everyone is usually familiar with this. We're highlighting only main important points which are relevant on an exam. If you are looking at an expression like this, you know in terms of the expression Keq, you will always equal it in the way that the products are listed in the numerator and the reactants are listed here in the denominator in the following way. The concentrations here with the coefficients serving as the exponents, and you can see that to be the case. And here obviously you're looking at the same items showing up always in this manner. But what are the most important aspects? It's the quantitative value of equilibrium expression. Remember, this right here is unitless. There is no unit which is attached to your Keq, so remember that. Anyhow, what are your cutoff points in terms of threshold? If a reaction is to be favorable, it should generally be much larger than 1. But what does this really mean? We're looking at something which is larger than 10 cube, 1000. If something is larger than 1000, then it is favorable in terms of the value, the quantitative value of this. What makes a reaction unfavorable? It is much smaller than 1. But what does that really mean? You are looking here at something 10 to the minus 3. Remember, we're not looking at values here which are negative. We're looking at values which are larger than 0 going in this direction. But your 1 serves as a cutoff point. Anything larger than, significantly larger than 1 is favorable. Anything significantly less than 1 but still larger than 0 is unfavorable. When you're looking at this, here we have 0.001. This right here is unfavorable. Then what makes a reaction in between? It's the values which you see right here in between, and I'll tell you exactly what I'm talking about momentarily. Between this range you have something which is equally favorable, equally unfavorable. But what does that mean from a chemistry point of view? Well, allow me to tell you by means of few quick examples. Imagine you have a reaction, we're just using letters here, x plus y. Don't pay too much attention here to the arrows, is gonna give you z plus w. The equilibrium expression over here is equal to 20. Now you evaluate this. What does the evaluation mean? Well, you know it's not larger than 1000, but it's larger than 1. It's not above that threshold, as I told you. Significantly larger than 1 would really imply this. Here you will have equal concentration of reactants and products. When this reaction reaches equilibrium, you have an equal amount, a generally equal amount of reactants and products. Now imagine the same reaction over here. The equilibrium expression over here is, let's say, 0.01. You know what that is. That's like 10 to the minus 2. Well, it's not significantly less than 1, where you're looking at a cutoff of 10 to the minus 3. So again, in the same situation, this is what you're seeing. When the reaction reaches equilibrium, you have a proportionate amount of reactants and products. Keep that in mind. These are between the cutoff points. They're inside the cutoff points, so you have generally equal amounts of these. Imagine now for a reaction, you have a value which is just significantly large, a huge value. Here you know you will have much larger concentration of products, or you might only see just products and you may see no reactants here at all, because that value is so much larger than that cutoff point I told you, 10 to the 3. Lastly, look at this example right here. We're looking here at now Keq, and let's say 2 times 10 to the minus 37. Now you have a value which is significantly smaller than this. It's larger than 0. It's larger than 0, but it's so much smaller than this and close to 0 that here you'll have a significantly larger amount of reactants, or you may only have this and you may have little to no products, because this reaction is so unfavorable. You have to keep in mind your cutoff points. So in review, let's tell you what the basics over here are. If you have something which is between 10 to the minus 3 and 10 to the 3 in terms of your equilibrium expression for that reaction, you have generally equal amount of reactants and products. This is what you have. The minute you go past this, you have more products in terms of concentrations. The minute you go in this direction, below 10 to the minus 3, then you have more reactants in that reaction at equilibrium. That's all I wanted to show you in this particular video. Have a good day.